Welcome to the first course on importing data in Python. My name is Hugo Bown-Anderson, and I'm a data scientist at DataCamp. In this course, you'll learn how to import data from a large variety of sources. For example, flat files such as TXTs and CSVs, files native to other software such as Excel spreadsheets, Stata, SAS, and MATLAB files, relational databases such as SQLite and MySQL. We'll cover all of these topics in this course. First off, we're going to learn how to import basic text files, which we can broadly classify into two types of files. Those containing plain text, such as the opening of Mark Twain's novel The Adventures of Huckleberry Finn, which you can see here. Those containing records, that is, table data, such as Titanic.csv, in which each row is a unique passenger on board, and each column is a characteristic or feature, such as sex, cabin, and survived or not. The latter is known as a flat file, and we'll come back to these in a minute. In this section, we'll figure out how to read lines from a plain text file. So let's do it. To check out any plain text file, you can use Python's basic open function to open a connection to the file. To do so, you assign the file name to a variable as a string. Pass the file name to the function open, and also pass it the argument mode equals R, which makes sure that we can only read it. We wouldn't want to accidentally write to it, would we? Assign the text from the file to a variable text by applying the method read to the connection to the file. After you do this, make sure that you close the connection to the file using the command file.close. It's always best practice to clean while cooking. You can then print the file to the console and check it out using the command print text. A brief side note, if you wanted to open a file in order to write to it, you would pass it the argument mode equals W. We won't use that in this course, as this is a course on importing data, but it is good to know. You can avoid having to close the connection to the file by using a with statement. This allows you to create a context in which you can execute commands with the file open. Once out of this clause or context, the file is no longer open, and for this reason, with is called a context manager. What you're doing here is called binding a variable in the context manager construct. While still within this construct, the variable file will be bound to open file name R. It is best practice to use the with statement, as you never have to concern yourself with closing the file again. In the following interactive coding sessions, you'll figure out how to print files to the console. You'll also learn to print specific lines, which can be very useful for large files. Then we'll be back to discuss flat files, and then I'll show you how to use the Python package NumPy to make our job of importing flat files and numerical data a far easier beast to tame. Enjoy. Now you know how to import plain text files. We're going to look at flat files, such as Titanic.csv, in which each row is a unique passenger on board, and each column is a feature or attribute such as gender, cabin, and survived or not. It's essential for any budding data scientist to know precisely what the term flat file means. Flat files are basic text files containing records, that is, table data without structured relationships. This is in contrast to a relational database, for example, in which columns of distinct tables can be related. We'll get to these later. To be even more precise, flat files consist of records, whereby a record we mean a row of fields or attributes, each of which contains at most one item of information. In the flat file Titanic.csv, each row or record is a unique passenger on board, and each column is a feature or attribute, such as name, gender, and cabin. It is also essential to note that a flat file can have a header, such as in Titanic.csv, which is a row that occurs as the first row and describes the contents of the data columns or states what the corresponding attributes or features in each column are. It will be important to know whether or not your file has a header, as it may alter your data import. The reason that flat files are so important in data science is that we data scientists really honestly like to think in records or rows of attributes. Now you may have noticed that the file extension was .csv. You may be wondering, what is this? Well, CSV is an acronym for comma separated value, and it means exactly what it says. The values in each row are separated by commas. Another common extension for a flat file is .txt, which means a text file. Values in flat files can be separated by characters or sequences of characters other than commas, such as a tab, and the character or characters in question is called a delimiter. See here an example of a tab delimited file. The data consists of the famous MNIST digit recognition images, where each row contains the pixel values of a given image. Note that all fields in the MNIST data are numeric, while the Titanic CSV also contains strings. How do we import such files? If they consist entirely of numbers and we want to store them as a NumPy array, we could use the package NumPy. If instead we want to store the data in a data frame, we would use pandas. Most of the time, you will use one of these options. In the rest of this chapter, you'll learn how to import flat files that contain only numerical data, such as the MNIST data, import flat files that contain both numerical data and strings, such as titanic.csv. But first, let's get you to do a couple of quick multiple choice questions to test your knowledge of flat files. Okay, so you now know how to use Python's built-in open function to open text files. What if you now want to import a flat file and assign it to a variable? If all the data are numerical, you can use the package NumPy to import the data as a NumPy array. Now, why would we want to do this? First off, NumPy arrays are the Python standard for storing numerical data. They are efficient, fast, and clean. Secondly, NumPy arrays are often essential for other packages, such as scikit-learn, a popular machine learning package for Python. NumPy itself has a number of built-in functions that make it far easier and more efficient for us to import data as arrays. Enter the NumPy functions, load text and gen from text. To use either of these, we first need to import NumPy. We then call load text and pass it the file name as the first argument, along with the delimiter as the second argument. Note that the default delimiter is any white space, so we'll usually need to specify it explicitly. There are a number of additional arguments you may wish to specify. If, for example, your data consists of numerics and your header has strings in it, such as in the MNIST digits data, you will want to skip the first row by calling load text with the argument skip rows equal to 1. If you want only the first and third columns of the data, you'll want to set usecols equal to the list containing ints 0 and 2. You can also import different data types into NumPy arrays. For example, setting the argument dtype equal to string will ensure that all entries are imported as strings. Load text is great for basic cases, but tends to break down when we have mixed data types. For example, columns consisting of floats and columns consisting of strings, such as we saw in the Titanic dataset. Now it's your turn to have fun with load text. You'll also gain hands-on experience with other functions that can handle mixed data types. In the next video, we'll see that although NumPy arrays can handle data of mixed types, the natural place for such data really is the data frame. Congrats! You're now able to import a bunch of different types of flat files into Python as NumPy arrays. Although arrays are incredibly powerful and serve a number of essential purposes, they cannot fulfill one of the most basic needs of a data scientist: to have two-dimensional labeled data structures with columns of potentially different types that you can easily perform a plethora of data sciencey type things on. Manipulate, slice, reshape, group by, join, merge, perform statistics in a missing value friendly manner, deal with time series. The need for such a data structure, among other issues, prompted Wes McKinney to develop the Pandas library for Python. Nothing speaks of the project of Pandas more than the documentation itself. Python has long been great for data munging and preparation, but less so for data analysis and modeling. Pandas helps fill this gap, enabling you to carry out your entire data analysis workflow in Python without having to switch to a more domain-specific language like R. The data structure most relevant to the data manipulation and analysis workflow that Pandas offers is the data frame, and it is the Pythonic analogue of R's data frame. As Hadley Wickham tweeted, a matrix has rows and columns, a data frame has observations and variables. Manipulating data frames in pandas can be useful in all steps of the data scientific method, from exploratory data analysis to data wrangling, pre-processing, building models and visualization. Here, we will see its great utility in importing flat files, even merely in the way that it deals with missing data, comments, along with many other issues that plague working data scientists today. For all of these reasons, it is now standard and best practice in data science to use pandas to import flat files as data frames. Later in this course, we'll see how many other types of data, whether they're stored in relational databases, HDF5, MATLAB or Excel files, can easily be imported as data frames. To use pandas, you first need to import it. Then, if we wish to import a CSV in the most basic case, all we need to do is to call the function readCSV and supply it with a single argument, the name of the file. Having assigned the data frame to the variable data, we can check the first 5 rows of the data frame, including the header, with the command data.head. We can also easily convert the data frame to a NumPy array by calling the data frame attribute values. Now, it's your turn to play around importing flat files using Python. You'll get experience importing a flat file that is straightforward, and you'll also get experience importing a flat file that has a few issues, such as one that contains comments and strings that should be interpreted as missing values. Have fun importing. We've seen a number of ways to read, print, and import flat files. As a data scientist, you will most often wish to use pandas. However, it was important to check out all the possible ways to import because you never know when they'll be useful. In the next chapter, we'll see just how useful pandas can be when attempting to import a variety of other file types, such as Excel spreadsheets, along with native SAS and Stata files. It's also important to remember that, due to the active development community in open source software, there is constant activity in file formats and ways to import data. For example, on March 29, 2016, Wes McKinney, the creator of Pandas, and Hadley Wickham of R development fame, announced a new and fast on-disk format for data frames for R and Python, called Feather. As data frames are one of the most important data structures for data scientists, let's definitely keep our eyes on Feather. After learning to import many other file types in the next chapter, you'll learn how to interact with relational databases in Python. Then, in the second part to this course, you'll learn how to tear all types of data down from the web and how to interact with APIs to fulfill your big data fix. These are all essential techniques for the modern day data scientist to master, and the upcoming chapters and course will place you in good stead to becoming an importing data ninja Pythonista.